layers that were developed to enable different networks to communicate reliably between disparate systems. Since this video is centering upon all things CCNA, it's crucial for you to understand the OSI model as Cisco sees it. So that's how I'll be presenting the 7 layers to you. Looking at this graphic, the OSI has 7 different layers divided into 2 groups. The top 3 layers define how the applications within the end stations will communicate with each other as well as with users. The bottom 4 layers define how the data is transmitted end to end. When looking at the graphic, understand that users interact with the computer at the application layer, and also that the upper layers are responsible for applications communicating between hosts. None of the upper layers knows anything about the networking or network addresses because that's the responsibility of the 4 bottom layers. You can see that it's these 4 bottom layers that define how data is transferred through the physical media, like through wire, cable, fiber optics, switches, and routers. These bottom layers also determine how to rebuild a data stream from a transmitting host to a destination host's application. The transport layer segments and reassembles data into a single data stream. Services located at this layer take all the various data received from the upper layer applications and then combine it into the same concise data stream. These protocols provide end-to-end data transport services and can establish a logical connection between the sending host and the destination host on a network. We can see this layer has 2 well-known protocols, Transmission Control Protocol, which is a connection-oriented protocol, and UDP, User Datagram Protocol, which is a connectionless layer protocol. For reliable transport to occur, a device that wants to transmit must first establish a connection-oriented communication session with a remote device, its peer system, known as a call setup or a 3-way handshake. Once this process is complete, the data transfer occurs, and when it's finished, a call termination takes place to tear down the virtual circuit. This graphic depicts a typical reliable session taking place between sending and receiving systems. In it, you can see that both the host application programs begin by notifying their individual operating systems that a connection is about to be initiated. The 2 operating systems communicate by sending messages over the network confirming that the transfer is approved and that both sides are ready for it to take place. After all of this required synchronization takes place, a connection is fully established and the data transfer begins. The network layer, or layer 3, manages device addressing, tracks the location of devices on the network, and determines the best way to move data. This means that it's up to the network layer to transport traffic between devices that aren't locally attached. Routers, which are layer 3 devices, are specified at this layer and provide the routing services within an internetwork. To define the network layer simply, it's logical addressing and routing through an internetwork. Logical addressing using IP or IPv6. Also at this layer, we have ICMP or Internet Control Message Protocol, which provides destination unreachable messages, for example, or gives us diagnostics with ping and telnet. The data link layer provides for the physical transmission of data and handles error notification, network topology, and flow control. This means that the data link layer will ensure that messages are delivered to the proper device on a LAN using hardware addresses, or maybe you call them MAC addresses or physical addresses, doesn't matter, and will translate messages from the network layer into bits for the physical layer to transmit. Now, the data link layer formats the messages, and we're going to call these frames. They add a customized header containing the hardware destination and source address. This added information forms a sort of capsule that surrounds the original message in much the same way that engines, navigational devices, and other tools were attached to the lunar modules of the Apollo project. And lastly, at the physical layer, we define how our networks are physically laid out. For example, our star topology is the most common physical topology today, and this is our Ethernet networks with LAN switches, where the cables come from all directions and plug into a centralized device. The logical topology is the signal path through this physical topology, and this is defined at the data link layer in the LAN driver. So in today's network, we have a physical star and a logical bus. So the signal runs from end to end across our physical star topology. In this section, I discussed the OSI model, the 7-layer model, which is used to help application developers design applications that can run on any type of system or network. Each layer has a special job and selects responsibilities within that model to ensure that solid, effective communications do, in fact, occur. Although this model is basically legacy, it still provides the foundation of what we need to know for our internetworking.